Hello! In this episode of Finnogric Machining, we are going to make the differential screw for this sturdy dial indicator stand. Well, what is this differential screw anyway? Let me show you a silly animation which might cast some light on this subject. In our case, the differential screw has two threads. One is M10 and another is M8. These have slightly different pitches. M10 is 1.5 millimeters per revolution, whilst M8 is 1.25 millimeters per revolution. When the bolt is rotated, the nuts are moving at a slightly different rate. The rate difference is the difference in the pitches, which in this case is 0.25 millimeters per revolution. This difference is used to clamp the dial indicator stand. This construction is robust yet light to operate. The material for the differential screw is M10 all thread. I am using the carriage stop and travel indicator to set a suitable length to be cut off from this material. I noticed that this stuff is not straight, and I really hope it doesn't have impact on the final product. The PVC tube here is not just convenient, it's a must. You shouldn't catch the part with your bare hands. Actually, it would be the vice versa. The part would catch your hand. Now I'm facing both ends and also establishing a center for the other end. The M10 end of this differential screw is now rounded to prevent laceration when using this device. Here I am turning down a portion of this workpiece to 8 millimeters, which is the major diameter for an M8 thread. I am using this round grooving tool since it can take the beating from the interrupted cut. This groove is for the thread to end into. The end of this differential screw is turned down to 6.5 millimeters. This portion will go into the hole in the cross pin in the handle. Here we have a good opportunity to damage the live center. Now I set up the lathe to make the M8 thread. First I check the M8 properties from my book. For M8 the pitch is 1.25 millimeters per revolution, the major diameter is 8 millimeters and the minor diameter is 6.466 millimeters. Now let's configure the lathe. In this table we have all the pitches that are possible with the change gear set I have currently installed. Well, 1.25 is nowhere to be seen, but we have one here, 1.26, and this is what we are going to use now. It is close enough. The two top levers must be set to positions S and R. Next, the internal gear set must be set to position 2. Then the multiplier should be set to position A. Then, for all this to be valid, a gear drive must be chosen instead of the belt drive. Last, the lead screw must be enabled. The lathe is now ready to turn the M8 thread. Well, that's all about the differential screw. In the next episode of Finnogrid machining, we are going to make the round joint for the stick. Till then, bye!